So I think we'll go ahead and get started. We have a lot to cover. And what I want to talk about today is, of course, at Google, we care a lot about speed. And hopefully that's something that you guys have experienced yourself across many of our applications, although I know we can still make them faster. And in the process of doing this, we've actually spent quite a bit of time and effort into developing better tools and just developing better methodology for how exactly do we make our web pages faster. So the intent of this talk is to actually give you a glimpse into the process that we use ourselves to analyze our own product, our own pages, so on and so forth. So in terms of logistics, we're going to take a look at a number of different apps. I'm going to try and give as many demos as I can, assuming the demo and Wi-Fi gods are with us. Hopefully that'll go well. And then at the end, there will be a lot of links. There's a lot of resources embedded in these slides. There will be a link to the slides at the very end, so don't rush to try to write down every short link and all that kind of stuff. It'll all be there. So with that, let's get started. So Larry Page made this interesting statement some time ago, which is browsing should be as simple and fast as turning a page in a magazine. Now, that's kind of odd, right? Like, is that really what we're aspiring to make our web pages feel like dead media? Well, not quite, right? The metaphor here is that when you think about the user experience of turning a page in a magazine, it actually works quite well, right? There's many other usability issues that come with the magazine. But the fact is, when you flip the page, it doesn't just kind of like stop halfway and not permit you to like turn it further, right? And then when you flip it over, all the content is there. It's not like it's just a blank page, and then 30 seconds later, or 10 seconds later, the content comes in and the ads pop up, and then like the whole page shifts down by 10 pixels because the iframe at the top showed up, right? That's what we mean by, that's the experience that we want when we reference this quote. And of course, we shouldn't stop there. It should even be faster. So with that in mind, we actually have an entire team at Google, and it's actually a fairly large team. The name of the team is Make the Web Fast, and I think you can infer what we're trying to do. And perhaps the most interesting aspect of this team is the fact that while we obviously spend a lot of time optimizing our own products, we also, the actual mandate or the goal for the team is to make the web fast as a whole, right? So we actually measure the performance of the team based on the entire web, the metrics around the entire web, which is actually pretty amazing when you think about it. So this obviously includes a lot of different optimizations. There's kernel networking, mobile, there's Chrome, there's infrastructure, data centers, our own routers, all that kind of stuff. So this includes research, working with standards bodies, building open source tools, and working with communities like the Ruby community to help make the web faster. So this is a really exciting field to be working in. So before we get into the specifics of how do we go about optimizing, it's good to get some baselines, right? So this is just usability engineering 101. And every month or so, we get a new case study or a new paper or some case study that comes out and says, hey, we lowered our page loading times and our conversions went up, or the sales went up, or something similar. And it's great to hear those stories because, frankly, I think we need to be reminded constantly of it. But the truth of the matter is, these numbers have been published by Jacob Nielsen, right, in 1993. He did a bunch of studies around what are some constants in terms of usability on a computer. And he found these kind of high-level buckets, which is if you respond to the user within 100 milliseconds, it feels instant. We can't actually tell the difference, right? It's 50 milliseconds or 100 milliseconds. So you're safe there. 0 to 300, it starts to feel sluggish. It's kind of like, that sticky button. You press it and something just didn't feel right. If you go over 300 milliseconds, all of a sudden you get this mental image of like, okay, the computer is thinking. Something is going on in the background. And then if you're over 1 second, then you just kind of context switch, right? You press the button and it's doing something, and then that other thought pops into your head and you're like, oh yeah, I need to do something there. And then if you don't deliver something within, let's say 5 seconds, let alone 10 seconds, the user's already doing something else entirely, right? That thought or that context switch that occurred at 1 second evolved into a full line of thinking that has completely took him off the course, right? It's like, I pressed this button and then I forgot what I was doing, right? It happens to me all the time, unfortunately. So these are the constraints. So we actually did some studies. We ran and we published these numbers on the Google Analytics blog. We looked across hundreds of millions of sessions on the web, and this is not specific to Google web pages. This is web as a whole. And we wanted to get some feel for how long do the pages, on average, take to load on desktop versus mobile. So here's the numbers. For desktop, we have the mean and the median, right? So the mean is the blue and the median is the red. So the mean loading time on desktop today is over 6 seconds, right? That's how long it takes to load a page, an average page on the internet. For mobile, it's much worse. It's over 10 seconds. Now, the medians are a lot lower, and that's good. But if you look at the histogram at the bottom, you can see that desktop is certainly faster, as you would expect. And by the way, this mobile data is actually very optimistic because we're using top-of-the-line devices to measure this, right? So these are your latest Android devices with multiple cores, likely in a good network. So for all intents and purposes, this is a very optimistic estimate. So if you're curious, we actually published all of the country-specific data and a lot more. There's a link down here on the bottom, so you can go to the Google Analytics blog and find that there. So 3 to 5 seconds, that's your average page load time. That's pretty bad. And what that means is, looking back to this chart that we saw earlier, is we're just on the brink of this, like, I'm thinking about something else and I'm just gone, right? It's a pretty terrible experience. Think back to that magazine metaphor that we thought about. What kind of experience would you have if you flipped the page and you had to wait 3 to 5 seconds for the page to load? Right? That's pretty terrible. But that's where we are on the web today, and that's what we need to improve. So, of course, one thing that we could guess at and say, like, well, let's look at the size of the pages, or what is making up all of this time. And maybe a little bit hard to see, but here at the top, we actually have a different project that's maintained by Googlers and a few others called the HTTP Archive. And what it does is, every month we go out and crawl some of the most popular pages on the web. So thousands of pages, CNN's, BBC, and all the rest. And we just collect all of the data, right? All of the images, all of the timing data, and all of the rest. And we're graphing it here over time. So you can see that from just November of last year to April of this year, the average size of a page has gone up from 702 kilobytes to just north of 1,000 kilobytes, right? So let that sink in for a second. The average size for a page today is basically a megabyte. That's crazy. And then at the top here, we have a different line, which is the number of requests. So for an average page, it takes 84 requests to render a page, and a megabyte in size, right? That's pretty bad. And we can actually break it up by the type of request. So an average page is 8 HTML pages. What? Right? Well, there's iframes, right? So we're requesting additional HTML resources. There's a ton of images, right, that we're requesting. In fact, they make up the bulk of the actual content or the download response. There's a ton of JavaScript, and there's CSS, and I'm actually omitting some of the other resources. But basically, the pages are getting bigger, and unfortunately, our networks are not getting that much faster, right? So we need to do something about this. So that's one good and interesting hypothesis, right? It's the pages are slow because we can't download them fast enough. But there's a lot of other things that come into the picture when you think about optimizing a web page. Think how the page is rendered when you first type in that URL. You click on the link. First, the browser actually has to unload everything that's in the DOM, right? Like, that's just garbage collection. It shouldn't take a lot of time, but it takes some time. Then you have to do the DNS resolution. Right? A lot of people here today were complaining about, hey, my DNS is timing out. That's usually a hidden cost that we don't think about, but it's there. There's the TCP and connection handshake. We have to make 84 requests in there, right? Some of those will share a connection, many of them won't. So each one of those takes time. We need to send the request, wait for the response, parse the response, and then, oh, by the way, we need to repeat this 85 times, right? So that's kind of cute. And then once we have all of the content, we actually need to parse all of the content and render and lay out the page, right? The beautiful thing about web apps is there's no install process, but we trade that off for an infinite install process, because every time you load the page, you're installing the page, right? So that's a cost that we need to take into account as well. So the question is, for your pages, where is the bottleneck? And there's only one answer to that, right? We need to measure all the things. This is step number one. Before we can optimize anything, we need to understand what it is that we're trying to fix. So one problem, though. Let me go back. How do we measure the DNS resolution time in your browser? We have no access to that data. How do we measure the TCP connection latency? We have no access to that. All of these things are very hard to get your hands on, or all of these metrics are very hard to get. But we do have one new addition to the standards, HTML5 standards and W3 standards, which will actually help us quite a bit. And it's called the navigation timing spec. So this was introduced last year, and this is actually a result of the work that our team at Google and a number of other organizations have been working on for some time. And the idea here is to expose all of that data from the browser to you, right, such that you can instrument this. So previously, you would have to write a native extension like a browser plugin, like a toolbar, to try and instrument and get at this data. Now all of this is accessible right within the browser. So each one of these, it's very hard to read them, but each one of these black labels at the top is actually a timer, right, that you can get at it. So navigation start, fetch start, domain lookup start, DOM complete, each one of these is a microsecond level timer that can give you the exact timing of how long did it take to do a DNS resolution. So that's pretty cool. And we have them colored in 3 different colors here. So the first part, which is the app cache, the DNS, the TCP, and making it the request, is basically the user's connectivity, right? If I'm sitting on my mobile phone and I'm trying to access a web page, all of that is effectively hidden from you as a Rails developer who's developing the app, right? But this definitely affects the user experience, what type of network, so on and so forth. Then there's the response, which frankly, that's where we tend to focus on. It's, I got a request on my Rails app server. I need to render it as fast as I can. And we have some very good tools that will help us drill in on this specific section. New Relic, analyze the logs and all that kind of stuff that will tell you that, hey, your active record is slow, or perhaps some other aspect of it needs optimization. And then finally, we get all of that content back to the client, and now the browser takes over and needs to parse all this content and lay out the page, right? So there's a lot of moving components. But the thing is, the user doesn't care, right? The user perceives the entire loading time as a sum of all of these components. It's not just the Rails stack. It's not just the browser time. It's all of these things. So that starts to get really tricky. So what is the state of navigation timing API? As of today, it's actually supported in IE, Firefox, and Chrome, right? So it's out there, and in fact, it has over 85% penetration at this point. It is available now on the latest Android browser, but as you can see, some of the other mobile browsers are working on it, but it's not there yet, right? So in terms of mobile coverage, we're not quite there, but it will be there. It's only a matter of time. So very exciting stuff. So let's take a look at what this actually gives us, right? We have the navigation timing spec, and it means that the browser can give you all of the detailed information about how long it took to load this page. So let me open up this guy here. Go to the console, and we can actually type in performance timing, and we get this object back, which gives us all of the timestamps for all of the events associated with DNS resolution, TCP connection time, so on and so forth. So this is really nice, because you can get this on every page, right? So now your client can actually look at this data and say, hey, you know what, that DNS lookup, it took me really long, which is why you experienced that slow load time. So that's nice, and you can find out more about how to use this by following this link later. But now you have a problem, right? This data is available to the client. It's not available to you as a developer. So now you need to collect all of this data, right? So you load the page, and perhaps you can write some JavaScript to extract these timers, send them to your server, log them, analyze them, and do all this kind of stuff. And that's great. But we have something even better, which is Google Analytics. So in fact, we are collecting this data in Google Analytics, and you can access it today right? There's no additional instrumentation, and you can just log into your account. I'm using the set site speed sample right here for one specific reason. So the way the sampling works today is Google Analytics will sample up to 10K unique visits per day, right? So we're not going to record this data for every single user because it's a lot of, frankly, it's a lot of data. But we have this max limit of 10K, or by default, we'll sample 5% of all of your visits. So if you have a site that's small-ish, as in it gets less than 10,000 unique visitors a day, you can just set your sampling rate to 100, and it'll sample across everybody, which gives you a really nice sample for how are users interacting with your site. So in fact, I have this set on my blog. And what this gives us is a number of reports within Google Analytics. So this is where we're going to tempt the demo gods. So this is actually my own blog, and we're looking at the content section site speed overview report, right? And you can see this average page loading time. And I don't want to talk about the 50-second load time. That's so you can see that, in fact, on my own pages, right here I am preaching about site speed, and my average page load time is 9.8 seconds. Oh my goodness. So let's go into page timings. So we can go into page timing and look at the technical tab. It's one of the more interesting ones. Come on, Wi-Fi. Maybe not. Okay, let's try this. So this is the same tab, but pre-rendered. So what we're looking at here is the technical report within Google Analytics for site speed. And you can see the average page loading time, average redirection, server connection, server response. Yes, you can get server response times within your Google Analytics without any instrumentation, which is pretty cool. So let's do some math here, right? So it took a user starts, they do a DNS lookup, 180 milliseconds. They connect to me. It takes on average 120 milliseconds, so that's 300. It takes me on average 300 milliseconds to serve a page, 600 milliseconds. And then the download time is roughly 170. So, less than 1 second is all of that connection time. But my average page load time is 9.7 seconds. Where did the other 8 seconds go? All right? So that's interesting. That's something we can drill into. Now let's see if this loaded. No luck. Oh. Let's try that again. I think it's just caching it. So how many of you here are familiar with Google Analytics Advanced Segments? Put up your hand. Awesome, awesome. So let's see if I can actually load this. So one of the things you can do is, this is probably not going to work, but in advanced segments, because you're using Google Analytics, you can actually segment out the traffic by any number of variables. Things like which country is the visitor coming from? Are they on mobile phone? Which browser are they on? Which browser version are they on? What screen resolution? So on and so forth. So we can actually, we're looking at performance data here. So we can actually say, well, I have a couple of different segments predefined in here. So for example, Asia versus Europe. There's some funny rendering artifacts there, but if I hit apply, oh, looks like the Wi-Fi is back. And it'll actually break out all of this traffic and give me the report comparing those two different segments, right? So visitors coming from Asia versus visitors coming from Europe, which is pretty amazing. And you can target this at city level and even deeper, right? So you can do very, very detailed analysis in here. And it doesn't look like it wants to cooperate, but here's an example, right? I'm, once again, pre-rendering Asia versus Europe. And you can see that, remember that 50-second spike? Well, it looks like Europe was fine, but for some reason, Asia really, really spiked. So it turns out that it's likely not an issue on my side. It's likely some resource, external resource that I'm requesting, which was just inaccessible or just rendering, took a really long time to render in Asia. So that in itself is a really good insight. So you can do all kinds of detailed and interesting things within Google Analytics. This is should be your first takeaway, which is to log into your Google Analytics and play with these reports. And you can do all kinds of cool things with it. You can set up PDF reports that will email you every Monday, Tuesday, Wednesday, whatever, and give you a summary of all of the performance associated with your site. So this is something we use extensively within Google. But one thing we need to be very careful of is averages, when you're talking about performance and timing, often lie, right? Because very rarely do you get a nice normal distribution for this kind of data. More likely, you're going to get something like this guy here, which is this really skewed distribution where the mean, the median, and the mode are, have a lot of space in between them. So to that, there's only one answer, right? You need to histogram everything because averages are misleading when you're talking about performance. And let me flip back. Maybe this guy will have faith in Wi-Fi. Well, we'll wait for it to try to load. But you can actually go to content, site speed, page timings, performance, right? So it's a little bit hidden, but it's in there. You can go into this tab within Google Analytics, and instead of giving you the averages, it will actually give you the histogram for each one of these metrics. So here we're looking at an example of, this is just my own site, and this is a kind of a case study I put together where back in January, I actually completely changed over my site, right? I moved it to a different server, I redesigned the pages, I migrated from WordPress to a statically generated site, all of these things. And here we're looking at the results, right? So this is December 1 to December 31st versus January 1 versus January 31st. And it just so happens that I made the flip exactly on January 1st. So this is just like perfect. So the one thing to notice here is it is, first of all, a distribution. There is this tail here, but you can see that starting January 1st, the peak of the distribution shifted up into the 1 to 3 second bucket, right? Which is a really nice improvement. We can actually show this to our clients or our users and say that, hey, there's a significant change in here. And we can also look at things like the server response time. And this is where the averages really get misleading, right? What is the average of this distribution? I don't know, it's probably half a second. But the histogram tells you a much more interesting story, which is there's actually this bimodal distribution in here. And I'm going to make a guess as to why that is, right? This peak here is when the page was pre-cached, right? So this is my blog running on WordPress. It had it stuck in memcache. It just served it fast. The user is happy. The other case is when I got a cache miss and it needed to go and render the actual page from database, right? So you can see these distributions, and it affects how your users perceive this. And then, of course, once I migrated to a static site, it's a very different picture. Most of the pages are very fast. There's this little dip in here, and it takes a little bit more. So histograms are incredibly useful, and that's what we use to analyze the performance of the pages. Averages are good, but look at the histograms. So just to recap some of the things we talked about, measuring user perceived latency is probably the most important thing you can do to help optimize the actual experience that the user has with your pages. Navigation timing is your best friend there, right? Up until very recently, it's been effectively impossible to get at this data. You can do that now, which is great. Google Analytics Advanced Segments, and of course, you don't have to use Google Analytics. You can collect this data on your own or use some other tool. But the advanced segments in GA can give you a lot of power to slice and dice this data. And then do set up some daily or weekly reports. It'll take you literally all of 2 minutes, and you'll get a weekly email that'll give you detailed performance data for free, which is very, very nice. So we talked a little bit about measuring, right? And what are the available tools that can help us measure all this stuff? Now the question is, perhaps I know I have a problem. What tools do I have to help me optimize around here, right? And there's a number of tools that Chrome specifically provides. There's a lot of other tools for other browsers. We're going to focus on Chrome. There's a network waterfall, which I think many of you guys are familiar with. There's a timeline profiler, which few people actually use, but is actually incredibly powerful. There's the CSS and a JS profiler specifically to help you optimize those specific components. And then there's this, some of this crazy stuff in tracing, which we'll take a very brief look at. So the network waterfall should not be new, I hope. Right? Let's try this. Let's open this guy. Go to the network tab and we're going to try and load CNN.com. So here it is, trying to stream over the web, right? And the reason we call it the waterfall is because the resources, as they get loaded, request more resources. There's network latency. There's blocking scripts that prevent other resources from being fetched. And you can see all of this data in here. And the shaded regions here actually tell you a lot of interesting things. It's stuff like, this is the latency. This is the actual download and the parse time, right? So it took us a while to make this first request, three seconds. And then we can see all of the different resources. So in fact, for CNN, it's trying to fetch all of these advertisement GIFs, which are getting us a 404. There's missing resources, all kinds of stuff. And as you can see, there is, in fact, over 84 resources that we're trying to fetch for a single page, right? It's remarkable that it works. And I'm not trying to pick on CNN. My own page took 10 seconds to load, right? The CNN pages actually take, as you will see in a second, about 15 seconds to load. So they're actually doing a lot of things right? They're fetching a lot of resources and managing to get it to you fairly fast. Whereas my page has like an image and an HTML file, and it's taking me 10 seconds. So perhaps they should be giving this talk. So then we have, let's go back to CNN. So this is very useful because it can tell you, what are the resources that are being fetched, how long did it take, some high-level stuff. The timeline, which few people actually use but incredibly useful, requires that we start recording, and then we can reload the page. So let's reload the page. And what it'll tell you here, so let's scroll down. Still trying to reload it. Come on. It'll tell you whenever each timer, oh, there we go. Oh, come on. Okay, so we'll take a look at this instead. So we have this chart here at the top, which tells you the JavaScript execution time, the layout time, and the actual network time. So JavaScript is busy all the way through trying to execute scripts and parse all of this content. We have download time here at the top, and we have the actual layout information, timing data that shows you what the browser is doing at any given point in time. And in here, you can see that we're trying to send different requests, right, for different things, and something caused a recalculation of the styling, right, so a reflow of the page. So you can drill into each one of these. So for example, here, I'm clicking on the evaluate script, and you can actually see which lines are getting invoked in the script, how long did they take, did the heap size change? Perhaps you're leaking memory, perhaps you're allocating a lot of objects. All of this data is detailed and available right within Chrome, right? So you can, going from the network waterfall, going to here, you can actually start analyzing specific scripts. So in fact, this one script in here on the CNN page fires something like 1,000 timers. I don't know why, but it's once you look at this data, it becomes painfully obvious. So those are the two tools that most people will use. The other one that I want to show you quickly is tracing. So this is definitely more on the edge. So I press record. Let me just try and do something on the page. Some security errors, sure. Let's go back, stop tracing. And now we get this graph here, which is actually a detailed view into exactly what the browser is doing, right? So if we started with the network analytics, we looked at, okay, this script is executing something on the page, and now we're looking at the internals of the V8, which says that, for example, let's zoom in on this region here, and we can look at the list here. You can see that render widget has been called 340 times. There's some web view layout implementations and all the rest. So you're likely not going to be using this to optimize your web page. A lot of people that are building HTML5 games or similar will find a lot of interesting data in here because it'll also tell you stuff about the GPU and other things. But this is nonetheless a very good resource to know about. You know, if you are optimizing your pages using this tool, talk to me. I'd love to know what you're doing because that's awesome. Okay, so DevTools gives you a lot of power and a lot of flexibility. But one of the things you may not know is that DevTools is in fact an HTML web app itself. There's nothing magical about it. It's not some native extension built into Chrome or V8 or anything similar. It's a web app, which is pretty sweet. So let's take a look at what this means. We'll actually demo this. You can actually run Chrome with a debugger or with debugging enabled. So I'll make this a little bit bigger. So what I'm going to do is I'm going to start another instance of Chrome with this special flag called remote debugging port, and you specify any port you want. So I'm just using 9222, which is the default. So I'm going to load that. We have another instance here. Just throw this to the side. Try and load a web page. There we go. Awesome. Responsive design for the win. Okay, so now we have the page here, right, which is nice. Let's go back to here. Get out of full screen. Open a new tab. So these are two completely different processes, right? This is the Canary build I have running here, and then there's the regular Chrome. And now what I can do is I can connect to port 9222. And hey, this looks familiar, right? There's the tab that I'm viewing in the other browser. So if I click on this, what would you expect? You get DevTools. So let's try that. Check it out. So we're looking at the DevTools for the page loaded in the other browser, right? So now we can do crazy stuff like, as I'm hovering over the DevTools in here, it's actually highlighting it in the other browser, which is pretty sweet. So we can go into one of these guys. Too many things in here. Right, and we can actually live edit this DOM, change it, modify some styles, do everything that you would expect. In fact, we could even load the network tab, reload this page, and see all of the data stream in directly. Right, so this is very, very cool. So you have all of the same flexibility and power. So why is this useful? Well, you can use this to debug your Android or on your mobile, right? So we actually announced Chrome for Android, and what you can do is you can hook up your phone via USB to your computer, load the page on your mobile phone via 3G or whatever network, and have all of the detailed performance data right within your browser on your desktop, which is pretty sweet, right? So that's awesome. What we can also do is, let me close this, is you can actually, Chrome also exposes a JSON endpoint that lists all the tabs. And one thing you'll notice here is it's giving you this WebSocket debugger URL. So what is that? Turns out, because the Chrome DevTools is actually just a web app, right? And actually, let me see if I can show you. Just to prove the point that there's nothing special about this, we can actually open the inspector on the inspector. All right, and we can go and look at resources. There's the damn guy, and like, you know what? I don't like resources, so I'm just going to delete it. Right, so there's nothing magical. So in fact, DevTools is a web app, and the way it's getting this data and the way it's talking to the other browser is through a WebSocket. So Chrome exposes a WebSocket or a JSON protocol that allows you to analyze all of this incoming data, all of the data that we got about the network timing. You can actually just get it raw. And I'll show you that by doing this thing here, which is, So I have this script which I'll run. And what it's going to do is it's going to connect to this browser that I'm running with the debugger. It's going to tell it to actually go to Twitter and search for RailsConf. And it'll just dump a whole bunch of networking data instead of printing it or printing it to the screen or laying it out in DevTools. So there you go. Right? We're loading RailsConf, and it's just scrolling text of hundreds and hundreds of requests that are happening live. And if I click on the All button, you can see more requests coming in, right? So this is Chrome fetching the resources, and it's spitting out all of the debug information about, hey, I started a DNS lookup, hey, I finished the DNS lookup, so on and so forth. So that's kind of cool. So let's go back. So we looked at that. So what are we doing here? What is that script doing? So it's actually just connecting to a regular WebSocket. And the first thing it does, it sends a command that says network enable. And what that tells Chrome is, hey, I want you to send me network debugging or network events. And then we send the second command which says, please navigate yourself to this specific URL, right? So search for RailsConf. And then just print out all of this data to the command line whenever you get a message. So very, very simple stuff. And here's an example, right? We saw a lot of scrolling text. This is just one of the events, which is response received. And I clipped most of it, but we can see that, for example, this specific request was an XHR, which is an AJAX request for trends on that specific page. It didn't reuse the connection. It didn't fetch anything from disk. Here's the timing data for when the request started, how long it took, so on and so forth. So there's a lot of detailed data in here, right? And you can, in fact, instrument your Chrome to set debug points, get all kinds of stuff directly from the CLI. So why am I showing you all this? Well, because I think there's a lot of interesting tools that can be built, right, through this debugging interface. There's not a lot today, but I think this is something that we as a community need to improve. And there's a lot of possibilities. So there's Chrome for Android, which allows you to do everything on mobile, all the same analysis on mobile. We have detailed stats on the network, on the DOM, on the GS, on the GPU, everything, right? We can do remote instrumentation even. So maybe a year ago, if we were having this talk, we could have stood here and lamented at the fact that there's no way for us to get at this data, right? There's no navigation timing spec. There is no remote debugging, or the remote debugging is very limited. That's not the case anymore, right? We've moved quite a bit just in the past year. So there's no excuse. The tools are there. Chrome is probably one of the most well-instrumented platforms you've ever developed for. So that's all cool, right? But now after this, you're like, well, Chrome is nice and fast, but how about IE, right? 8 in Singapore on a DSL modem. Well, we have an answer to that too. So there's another project that actually started at AOL, but it's now being maintained by a couple of Googlers and a few other companies called webpagetest.org. So if you guys are not familiar with it, awesome, awesome resource. Let me show you what we can do. So we can go to the webpagetest.org, and we can actually pick a number of sites and a number of browsers. So here, I'm literally running a test from Singapore on IE8 with the characteristics of a DSL connection, right? And I'm trying to load CNN.com. And what it spits out is this waterfall chart directly from IE8, and you can interact with it, assuming this works. Actually, I have it preloaded here. So here are the results, right? It tells us that the first view took about 10 seconds. The second view, because some of the resources were cached, took about 4.5 seconds. We have this detailed graph here. In fact, you can see the waterfall difference between the first request and the second request, right? So caching definitely helps. We can also go into content breakdown. This is a very interesting section. I think I have it preloaded here. There you go. Oh, no. So this is the waterfall view, right? So you can get detailed analytics for all of the same stuff directly from IE8. You can click on this. Oh, maybe not. Not right now. Oh, it's loading. So you can click on each one of those, and you can get all the same stats about DNS connection time, TCP time, and all the rest. So you can do this kind of analysis across the different browsers. Of course, it's not as well instrumented as, for example, Chrome, but you have the tools. So another thing that the web page test will give you is actually, let me go back. You see this screenshot? This screenshot was taken directly from IE, and one of the things that web page test does is it records everything frame by frame. So it can actually give you a video of how the page loaded. So this is the video that it captured for me, right? So let's play it. This is IE. So we're loading for about 3 seconds. 4 seconds in, we get some content. 7 seconds in, we get the images. At 10 seconds, the DOM content loaded is fired. And about 12 seconds in, we get the ads. And about 13 seconds in, I don't know if you guys caught it. Nope. We shift all of the content down by about 15 pixels because we load the header, right? Awesome, awesome experience. So, and once again, I'm not trying to pick on CNN. I think they're actually doing a lot of things right? But it's just, it's tough. There's hundreds of requests that are being made here. The ads are coming in, the images, everything. So web page test can give you this data. And this is actually a very interesting way to look at how the page is being rendered. In fact, we spent at Google a lot of time thinking about this problem, right? It's not the case that we just want to measure the final completion time, right? At about 15 seconds. The page is, in fact, you can sort of interact with it as soon as 4 seconds in, right? Like the content, some of the content is already there. The images come in at about 10 seconds in, but you can still do something. So how do we measure this, right? How do we measure this visual completeness? Because it could be the case that the page takes 20 seconds, but you can, in fact, do a lot of stuff even 1 second in. So we introduced this new metric, or we're playing with this new metric called the speed index, which is a way to measure or quantify how quickly the page visually gets populated. So how are we going to do this? We're going to take a look at the same page, right? So we're going to render 2 film strips. Think of it as step 1 as just render 2 film strips. Same pages, right? So web page test. At the top, we're going to have an optimized page, and on the bottom, the unoptimized page, right? So here we're capturing frames about 1 second apart. And 1 second in on the optimized page, most of the page is pretty much rendered. It's already there. On the unoptimized page, you can see that the body is still missing, right? So now we have these 2 film strips. So now we can kind of eyeball this, and we can plot this and say that at 1 second in, roughly, let's say 90% of the top one is there visually, whereas 15 or 20% is there for the bottom one. So we can actually produce a graph like this that says, okay, 1 second in, we're 90% done. For the second page, we're about 18% done, right? So we can plot this over time. So then we do this trick, which is to calculate the score, we actually look at the area above the graph of one of these lines, right? So very simple trick. So basically, we're looking at the area, we're computing the score, and the lower the score, the better, right? So you should aspire to a score of 0. Of course, you're not going to get it, but the lower the better. How do we actually determine? Right, so this is cute when you sit down and you kind of do this manually, but how do we do this programmatically? How do we give you this number? There's a lot of different ways that you can determine how complete visually the page is. It's actually a very interesting and tough problem if you think about it. We're using a simple trick which seems to work pretty well right now, which is a color histogram. So we look at the distribution of colors on the page, and it turns out to work actually quite well, at least for the apps that we're looking at this point. So the speed index number is actually available on webpagetest.org, right? So you can see that the repeat view has a much lower speed index score. That's what that speed index score is referring to. So very useful metric and something that we've been paying a lot of attention to, or playing with, rather. So a quick recap. So web timing API, we talked about that. Google Analytics, very useful. Chrome DevTools to help you optimize the page in your browser when you're trying to figure out what's going on. You should absolutely test your pages in other browsers, right? In other geographic locations. Web page test can help you with that, and it's a free app, which is great. And then speed index is an interesting way to kind of quantify how fast your pages are loading, because the load time itself often hides some of the nuances in there. So now, right, we've talked about what we're trying to measure. We talked about the tools. Now we need to actually get to the optimization part. So there's a lot of different tools out there. I'm going to talk about one family of tools that we've been working on, which is Google PageSpeed family. And there's a number of different products in here. There's online SDK and a few others. So online service will basically allow you to just type in your URL, and will run a bunch of heuristics and analytics on your page and give you some recommendations. So I preloaded this. I'm running this test on railsconf2012.com, and it gave me a score 75 out of 100. It's a little bit hard to see there, but 75 out of 100. And on the site here, it's actually giving me a number of recommendations. Things like, hey, here's some high priority fixes that you should apply, right? Leverage browser caching. So it turns out railsconf2012.com is actually not setting expiration dates on most of its CSS or JavaScript resources. So every time you load the page, you're forced to re-download everything over and over again, right? So very simple things. There's stuff like, hey, it looks like compression's not enabled either. You can combine multiple images into CSS sprites, so on and so forth. You can actually defer some of the scripts. So for example, RailsConf is using Google Analytics, but it's using the synchronous version, which means that while it's trying to load the ga.js file, nothing else on the page is being rendered, right? You can load that asynchronously and speed up the page load time. So there's a lot of recommendations that we will give you. And in fact, there's a lot of things that are gone well. There's 15 things that, rules that passed successfully. So give it a try. Just type in your site name, any specific page, and we'll give you some recommendations. So that's PageSpeed Online. PageSpeed Online also has an API. So you can easily automate this and run this periodically or for specific pages. You can set different strategies, things like, hey, I'm actually interested in optimizations for a mobile experience. So we have some different rules for mobile as opposed to desktop. You can tell it to run specific rules, so don't run the whole battery of 50 plus statements, just run this one specific one. And it's all available there via JSON. You just need to get an API key and go nuts. Build widgets, all kinds of stuff. So that's nice. But one of the problems is, sometimes you're developing something locally or perhaps on your internal network. You can't run an external tool on one of those pages. So one of the things we have is all of the code, all of the rules behind, all of the code behind all of the rules is in fact open source. We have an SDK, it's available, and we've actually made Chrome and Firefox extensions that you can install directly in your browser and run on any specific page. So if I go to this guy, I actually have PageSpeed installed, so I can click on this, hide this guy, and I can run PageSpeed on this specific page. And it probably won't work at the moment because the Wi-Fi is not cooperating. But you'll get a report very similar to the one that you saw on the online resource, which you can expand, and it'll give you specific recommendations for each and every page there, which is very nice. So that's cool, right? But now we've given you all these rules, we made all the recommendations, so why not just automate it, right? And we can do that too. So another project that's part of the PageSpeed family is this plugin that we've been working on for Apache called Mod PageSpeed. So how many people here run on Passenger? Okay, so a fair number. So I would definitely encourage you to try Mod PageSpeed. It's basically a drop-in output filter. So what happens is Rails or Passenger serves the content. It then goes to Mod PageSpeed. Mod PageSpeed runs a whole bunch of rules on that content, and we'll actually look at some of the rules in a second, but it can do all kinds of optimizations. Obvious things like combining JavaScript and CSS into single files. So sort of like the ACID pipeline. But it'll do much more. So for example, in here, I'm showing you some of the directives that you can pass in. Things like, if the CSS is smaller than 2048 bytes, just inline it. If JavaScript is small, inline it. If images are small, inline it. By the way, compress all the images for me automatically. Do all of this for me, right? You don't have to touch your code. It'll be done directly in Apache and served to your users, which is very, very nice. You can apply things like remove all the comments because your user's not going to see them. So to make it work, right, enable passenger, enable mod page speed, and you should automatically inherit a lot of this performance. So one of the things I will say is we haven't made it very easy at this point to make it work. So and that's something I'm hoping we can improve in the coming months. So if you guys are working on this and trying to make it work, ping me. I'd be happy to make it work, and I'd love to see some good case studies on this. So let's see if I can load the filters. There's a lot of different filters that I can apply for you. Doesn't seem like it wants to load. So that's cool. That works for Apache, right? But a lot of you were not running Apache. So we also have this other service that's currently in beta. It's limited beta, only available to a few customers, but we're playing with, which is PageSpeed as a service. So what you would do is you would actually just set your CNAME to one of the Google servers, and we would automatically do all of this work for you, right? We would optimize all of your pages, all of your CSS, all of your JavaScript, and also serve it from the Google CDN, which we have a few servers lying around the world. So that should be a pretty significant win, and I'm really, really excited about the service. So stay tuned for more. We're going to have some great announcements later about it. So I'm really excited. So we're out of time, and there's still so much more to cover, right? We didn't really talk about mobile optimizations. We talked about Chrome for Android, but there's a lot more to be said there. There's JavaScript and CSS. Those are entire talks unto themselves. We have the WebP project, which is trying to improve image compression. If you think back to the CNN example, most of the 600 kilobytes out of that 1,000 kilobytes were images. If we can give you a 10% saving on image compression, that's huge, right? We'll be decreasing the load times by a significant amount. There's a lot of TCP and SSL and kernel optimizations that we've done internally at Google and also pushed upstream and trying to push more patches upstream. And of course, there's Speedy, which is, if you will, an HTTP 2.0 proposal, right? Which is now an IETF spec proposal. So lots of exciting stuff going on in there. So with that, just a few concluding thoughts. The first thing you need to think about is, what do I need to measure, right? Before you stare down that SQL query that's been offending you for the last 6 months, go and look at your page load times. Figure out where the actual bottlenecks are, because chances are it's not the SQL query. Chances are it's that JavaScript file that you don't even control, right? They just kind of put there. It's that social button from some unknown network that is now down, right? That's delaying everything by 2 seconds. Second one is measure user perceived latency, right? So that's just a hint. From our experience, measuring that is the most important thing they could optimize. Optimize from user's perspective. Don't focus on that SQL query. Focus on the user's perspective. Use that as a forcing function. Keep in mind that mobile is a lot slower, right? And 1.5 is a very optimistic estimate. So there's a lot to be done there. The tools are there, right? Or largely there. There's been huge, we made huge advancements just in the last year. But of course, there's also opportunity to build more and better tools. And I'm hoping that you guys can actually help us do some of that work as well. So with that, you can see the slides. So there's the bit.ly faster Rails. All the resources are there. And I don't know if we have time for questions, but I'd be happy to take any questions.